Hey guys, this is Dr. Callahan with Calculus AB for week 13 Thursday. How are you guys doing? Go ahead and pause the video and take a look at the following three questions for your warm-up. All right, let's go ahead and just jump right in. So last time when I saw you guys, we talked about concavity for the first time. And today we're going to continue on with concavity, but more importantly, I want to make sure I review a few other things, such as a Rolle's and mean values theorem, in addition to related rates. And then I have a poster rotation of Rolle's and mean values theorem, and then also concavity. So take a look at the breakdown for today. Go ahead and turn over to your guided notes today, which is on week 13 Thursday. So this is going to be our first guided notes of the 4 questions that we will go over in class. This is a video guided note right here. You can actually view the video right here on the link below. And with that said, let's just go ahead and jump right in. Okay, we'll start off over here with the first example. Go ahead and take a look at that. Okay, it says find the two intercepts, x-intercepts of f of x squared minus 3x plus 2 and show that f prime of x equals 0 at the same point between the two x-intercepts. So to find the x-intercepts, I would have to go ahead and set the y to 0. So then looking at this part right here, you have x squared minus 3x plus 2. So then we're going to go ahead and say let y equal 0, solve for x. So then I'm going to have this equal to 0. I know I can factor this part out. I ask myself, what times what gives me a negative positive 2? But when I add it together, it gives me a negative 3. That'll be negative 2 and negative 1. And then when you solve that, x equals a positive 2 and a positive 1. So these are your x-intercepts. So then what I'm going to do here is I'm going to find the first derivative of f prime of x, which is just going to be the power rule. Set it equal to 0, solve for x, which is a 3 over 2. And then what I'm going to do is I'm going to take these two and I'm going to set them equal to each other. So what it's saying is that when f prime of x is going to be at 0, it is going to be at 0 at x equals 3 over 2, which in this case, 3 over 2 is the same thing as 1.5, which also lies in 1, 2. So it does include that the point between the two x-intercepts. All right, example 2. Let f of x equals 4x to the fourth minus 2x squared. Find all the values of c in between negative 2 and 2 so that f prime of c equals 0. So let's go ahead and find the f prime of x first. It's just a simple power rule, 4x to the third power minus 4x, set it equal to 0. I'm going to go ahead and factor some of this out. I could take out an x and a 4, and then I have an x squared minus 1 equal to 0. So I can go ahead and factor this a little bit further. It's a special factorization because a negative 1 and a positive 1 gives me a 0x, but negative 1 times positive 1 still gives me a negative 1. Set equal to 0, solve for x. So 4x equal to 0, x minus 1 equal to 0, x plus 1 equal to 0, and you should get x equals 0, x equal to 1, x equal to negative 1. These are your values, in this case, for C. So in this situation, C is equal to 0, 1, and -1. Example 3. Example 3 says, given that f of x equals 5 minus 4 over x, find all the values of C that is a 1, 4, such that f prime of C equals the average rate of change. So let's go ahead and find the f prime of x. Now with this one, your derivative of 5 is just a 0. So then you have a -4 over x. Now with this, you could do one of two ways. You could either do the quotient rule, or I can just move my x over, so I have a -4x and -1 power. So then when I go ahead and find the derivative of that, I'm going to bring that down. So that's a positive 4x and a -2nd power, or just 4 over x squared. So then I'm going to have 4 over x squared as my f prime of x. And then I'm going to go ahead and apply the f of 4 minus f of 1 over 4 minus 1. F of 4, you just plug it into this equation, is going to be a 5 minus 4 over 4. So that's a 5 minus 1, which is a 4. Then I'm going to do f of 1, so that's a 5 minus 4 over 1, which is 5 minus 4, and that is a 1. Well, it's a 3 over 3, so that's going to give me a 1. And so then I'm going to go ahead and set the two equal to each other. So 4 over x squared equals 1 over 1. Cross multiply it, 4 equals x squared. If I square root both sides, x equals a positive and -2. Now, you want to be very careful with this because your interval is between 1 and 4, so x can only equal to 2, and that is the only value that you have for C between that interval. All right, next one, here we go. Two stationary patrol cars equipped with radar are 5 miles apart on the highway. As a truck passes one patrol car, it speeds and is clocked at 55 miles an hour. 4 minutes later, when the truck passes a second patrol car, its speed is clocked at 50 miles per hour. Prove that the truck must have exceeded the speed limit of 55 miles per hour at some point in the 4 minutes. All right, let's go ahead and take a look at this. So t is my time, is going to be, if you look at the first one, is 4 out of 60, because it's 4 minutes out of 60 minutes, which is 1 over 15 hour, okay? S of t is going to give you the distance. So then S of 0 is going to give you 0. S of 1 over 15 is going to give you 5. So then there are two conditions. We must check this first before we proceed any further. First one is your function continuous? And is it differentiable? And yes, it is. So then we're going to go ahead and do S of 1 over 15 minus S of 0 divided by 1 over 15 minus, excuse me, 0, which is going to be 5 minus 0 over 1 over 15, which is the same thing as 5 divided by 1 divided by 15, or times 15 over 1, which is 75 miles per hour. All right, you guys, so to have you practice with this a little bit, I have a poster rotation. I have the steps with it as well, but the questions on top. So try to do the questions on your own before you take a look at the answers and steps. So pause the video and give this a try. Here's the second one. Sorry if I'm going a little fast. There are 10 of them, and I want to make sure I get to the leader rates questions as well. Here's the third one. Here is the fourth one. Here's the fifth one. Here's the sixth one. Seventh one. Here's the eighth one. Ninth one. This one is going to require you to do the concavity. And the very last 10th one. And this is a concavity using trig functions. All right, so make sure you guys get those practice in, and then we're gonna go ahead and get started on a few of the related rates questions. Now, this one is not in your guided notes. I thought it was kind of prudent to be able to do a little bit of this beforehand, and but you do have access to this just by looking at the problems in the video. And also, if you need to take a look at the answers and steps, I do have a link on the very bottom as well. So it's a capital S, capital N, everything else is lowercase. All right, let's take a look at the question here. It says a man who is 6 feet tall, so there's a little man right there, is walking away from a lamppost at a rate of 5 feet per minute. The lamppost is 20, I'm gonna put little lights here so I know that's a lamppost, 20 feet tall. The person casts a shadow on the ground in front of them. How fast is the shadow growing when the person is 30 feet away from the lamppost? And how fast is the tip of the shadow moving when the person is 30 feet from the lamppost? So a few things here. And it's given to you that, remember, dx over dt is the rate of the person walking. And if you think about it, it's actually giving a few hints here. It says a man is 6 feet tall, but he's walking away from the lamppost at a rate of 5 feet per minute. So that tells me that the dx over dt is 5 feet. Actually, it's not minutes, second. That would be really slow while walking. So 5 feet per second. And it's also telling me that this x value here is 30. The lamppost is 20 feet tall, okay? And then the person casting a shadow from ground from front of him. Okay, so a few things. dy over dt is a rate of change of the shadow's length. And dx over dt plus dy over dt equals a rate of change of the tip of the shadow. So with that said, let's go ahead and go back to geometry when you do proportions. So we're going to first set this up with the height of the man and his shadow, so 6 equals y, as a ratio of the lamppost, and the lamppost goes with a 6, over the entire length, so the length of the person and then also the x right here, and the shadow and the length of x, so x plus y. So let's go ahead and cross multiply. I have 6 times x plus y equals 20y. Distribute 6x plus 6y equals 20y. I want to make sure I have my x's and y's together, so leave the x on the left side, move the y over, and you have 14y. So I'm going to start off with this equation, and then you're going to apply the implicit differentiation to this equation. The derivative of 6x is just 6, but you have a dx over dt, plus the derivative of 14y is just 14 equals dx or dy over dt. Given the fact that the first question A says, how fast is the shadow growing? So the shadow growing is going to be find dy over dt because that's the shadow right here when x is equal to 30. So 30 feet away from the lamppost. So once I have this part right here, it is given to me that dx over dt is 5 because the person is walking away from the lamppost at 5 feet per second. So 6 times 5 equals 14 dy over dt. At this point, I think you kind of see where we're going with it. So 30 equals 14 dy over dt. Divided by the 14, I have a 30 divided by 14. But if I reduce it by 2, it's a 15 over 7 equals dy over dt. So what does that mean? So for A, the person is walking at a rate of 15 feet per second. And that is A. Okay, so then we're going to look for B. So for B, it's asked that dx over dt plus dy over dt is equal to the rate of change of the tip of the shadow. And it says, how fast is the tip of the shadow moving when the person is 30 feet away from the lamppost? So then what we're going to do with this is I have dy over dt, or dx over dt plus dy over dt equals the rate of change of the shadow. Well, the change of the shadow is going to be the rate of how fast the person's walking x right here with the y right here. So then you know that the person's walking away 5 feet per minute plus change dy over dt, which is going to be 15 over 7. So then if I go ahead and I find my common denominator, there's a 1 right there. If I make that a 7, that's going to be a 35. And then together, that's going to be 40, 50 over 7, which is just going to be 50 over 7 feet per second. And that is your answer for B. All right, so I'm going to have you guys go ahead and take a look at question number 2 and pause the video and give that a try. Okay, so here are the steps for the answers as well. So take a look at my work and take a look at yours. All right, you guys, let's go ahead and take a look at this question here. It says a conical tank vertex down is actually, you know what? I feel like we've already done this one before, so I'm just gonna skip it. You can take a look at the answer here. I feel like at one point we did do a question similar to that one. So let's go ahead and try a different question then. All right, let's go ahead and do this one here. This was in the 2003 AB problem number 5. It was a free response question. And as the coffee pot has a shape of a cylinder with a 5 centimeter radius, with the figure shown below. Let h be the depth of the coffee in the pot measured in inches, where h is a function of time measured in seconds. The volume of the coffee pot changing is at a rate of negative 5 pi times the square root of h, cubic inches per second. And it's given to you that the volume of the cylinder is volume equals pi r squared h. Find dH over dt. That's actually really nice that they asked you to find dH over dt because most of the times they don't tell you that. As a function of h, this means your answer will have to contain the h variable. Okay, So then what we're going to do is it is given to you that the volume of the coffee is changing. So the volume of changing for the coffee is dV over dt equals a negative 5 pi square root h. It's also given to you that the radius is 5. Inches. And also the volume of the cylinder is pi r squared h. Okay. Well, it's given to you that the radius is 5, so let's just do 25h. And don't forget, oh, no, I have the pi there. Never mind, it's good. So my volume is 25 pi h. Okay, now I want to go ahead and convert this into the derivative. So derivative of v is going to be v prime, but in this case, we want to be consistent with how it's written. So another way of writing v prime is dv over dt. Given that 25 and pi are constant, you just write 25 pi, and then you just find the derivative of h. The derivative of h is 1, but because you're finding the derivative of h, you have to include a dh over dt. Okay, that's exactly what we want to find right here. So let's go ahead and substitute the dv over dt with a negative 5 pi square root of h. So I have a negative 5 pi square root of h equals 25 pi dh over dt. Well, I want to just go ahead and find dh over dt. So how do I get rid of the 25 pi? Well, opposite of a times is a divide. So negative 5 pi square root h divided by 25 pi equals dh over dt. So then I'm going to go ahead and cancel the pi, cancel the 5 over 25, which is a 1 over 5. And then my answer is just going to be dh over dt is going to be equal to negative square root of h over 5. Don't forget your units, inches per second. And that is my answer. All right, you guys, so that is basically it. Quite a bit of stuff that we went over, if you ask me. If you would like to go ahead and do a little bit more, I do have a Quizlet right here that you can go to. It's going to help you with concavity. And so it is basically going to give you questions, and it's like a multiple choice, and you just click. There are 19 questions, or actually 20 questions altogether. So you can go ahead and practice that a little bit. Now, if you can't see it, it's because I didn't screen share it, but now you can see it now. So yeah, this will be the last part of your stuff today. And here is a link right here. It's just Quizlet.com/252772132/learn. All right, you guys, I hope you have a wonderful day. As always, stay safe and healthy. I'll see you guys next time. Take care.